Hello and welcome to CS230 Web Information Processing. This is week 8, and in this lecture, lecture 15, I'm going to provide you with an overview of database-driven web development. It's the second lecture in a series of 2, and this time I'm going to be looking at NoSQL document designs that can be used for web development. Previously, we looked at relational database models and how they could be used to drive applications for running on the web, mostly back-end stuff, and we were using MySQL or MariaDB, and we used those in conjunction with Node.js and PHP. This time, in this particular lecture, I want to give you some theoretical background and underpinnings of a different approach to database design, and that's they're called NoSQL databases. And there are lots of them, and we see that a little bit later as we work through the lecture. But the one in particular we're going to be interested in is the document style or document variant of a NoSQL database that we'll be using to drive the back end of the next round of web apps that we're working at in this module. Okay, so we're here in week 8, as I said. We have one series of 2 lectures left in this particular session, where we're going to try to pull together and have an overview of the differences between LAMP and mean, and that happens next week. And then we'll be finished, 3/4 of the module. Okay, it's important to note that there's been a slight change to the lecture schedule. In case you missed last week's lecture, that this particular set of lectures and last week's lectures were reorganized because we're mostly working offline at the moment. Okay, so today's lecture will mostly focus on introducing the database design for use to web apps built around a NoSQL database. So we're going to learn about NoSQL databases, how we get started with the MongoDB document database, and then we're going to learn a little bit about modeling documents for use in NoSQL-driven web applications. We complete this section tomorrow's lecture. That'll be the short lessons where I'll go through a lot of practical stuff. So this particular lecture is going to go through some of the theory and a little bit of the background and focus on the bigger picture. It's not necessarily about programming per se. Okay, so what's this NoSQL? So let's see what's going on in the NoSQL database world. We're fairly familiar with MySQL at this stage and the relational database world, and sometimes that's referred to as the RDBMS world, Relational Database Management Systems. Okay, so we've been using these RDBMSs for conceptual, logical, and physical representation of the data that we used in a web application. Well, we used relational database modeling, and ultimately that made its way into a relational database in terms of a physical database. It's very traditional, it's workable, it's a very solid solution, but it's not always appropriate for our designs because it requires a very singular perspective on the structure of the underlying data. In other words, it needs to be tables and have relationships between those tables. Or, sorry, it needs to be tabular, I suppose, is a more accurate way of saying this. So, but modern data are not necessarily structured as tables. And it can be inappropriate then to organize them as a table for processing purposes because you may lose the key information embedded in the structure itself. So if you have data, for example, that's organized as a graph, and then you try to convert this graph into a table, and then you try to do something with that table or that graph, that's realized as a table, you might lose the features that make it a graph. So, and we understand how to query graphs. You've done tree searching algorithms yourself, I suppose, in some of the other modules. So if we could organize and store the data as a graph, then we could query the data using some graph-based query language, for example, rather than reorganizing it as a table and then using a structured query language, I guess, SQL out, So we want to try and avoid that if we can, because, we're now looking at very, very complex data structures in the big data world and data modeling world. And we need alternatives to tabular structures. So that's what we're doing in this NoSQL database world. So data organized as documents, for example, as well, they might not be suitable to tabular organization. And it may be necessary to have collections of documents that are related but don't have the same structure. Or they might have some kind of loose organizational structure or some schema associated with them. So NoSQL then, came about in around about 1998, okay? And it stands for not only SQL. It might sometimes be referred to as NoSQL or not SQL. because it doesn't include SQL, I guess, But it's an approach to database design that provides flexible schemas for the storage and retrieval of data beyond the traditional table structures that we find in relational databases. It's a non-relational database management system that doesn't require a fixed schema. It avoids joins, it scales easily, and is used to create distributed data stores that have extremely large data storage requirements. We saw a little bit of joins in our assignment last week where we had tables and we had relations, and then we had to join 3 tables in order to be able to find something out. And I did this in the lessons with you already. So we're avoiding that kind of thing when we start moving over to a NoSQL scenario. So, as I mentioned already, NoSQL is used for big data, for real-time web applications, and is used by big companies like Twitter and Facebook and Google, who collect terabytes of user data every single day. Can you imagine all of the tweets that are happening now? And we want to be able to record and store all those and organize all those. Tables aren't the best way to go. So NoSQL databases are said to scale out better than relational databases, and they're designed to work well with web applications and web applications that require or utilize huge amounts of data. And scaling out refers to distributing the database load on multiple hosts whenever the load increases. It's a much better approach than, say, scaling up systems, and that means that you upgrade the existing hardware, and that can be quite an expensive process, So, and I'm sure you've heard about NoSQL databases in your other modules on databases already. I mean, databases are a requirement for this particular module, CS230. So I'm sure you know a little bit about them already. So again, I'm just going to review the features of NoSQL databases here. I'm not going to go into all of them in any great amount of detail. And then we jump right into using MongoDB for use with our applications, our web applications. And we see that tomorrow in the short lessons. So the main features of NoSQL databases are they're schema-free, they're eventually consistent, okay? So, and it's consistent in terms of what's called the base property, and we explained a little bit about base via down here, okay? Replication of data stores to avoid a single point of failure is really, really important, or a feature of them, and they can handle data variety and huge amounts of data, okay? So base refers to basically available soft state eventual consistency model, okay? Where basically available means the availability of the data. I mean, there will be a response to any request, including a failure. So if I say I want to get something, the database will always respond and let you know, even to tell you it can't find it, there's nothing there. Soft state means that the state of the system can change over time. It's not fixed. So, that's a very useful property. Eventual consistency means that the system will eventually become consistent once it stops receiving input. Okay, so it stabilizes in some way, and the data will be available, without change from there on. Okay, so that's really it, and that's the way it works. So how does that happen? So in order to understand how that happens, we realize that there are actually a few different ways of making this happen. So that means there are going to be different kinds or types of NoSQL databases. So there are 4 main categories. And so here's a list of the 4, and I also give some examples, and you'll find these elsewhere in the references for the actual implementation, the software implementation of this particular model of NoSQL. So where you would have seen before with relational database models, you could look at MySQL, PostgreSQL, Oracle, these big systems, but they're still all using tables, and that's par for and they all use SQL to query those tables, So first one we're interested in, or see, is the key value pair stores. And an example of this is, for example, DynamoDB. Wide column oriented graphs or stores, okay, and that's Cassandra HBase, for example. Graph type databases, the most famous one of these is Neo4j, and we do some work in the department using Neo4j to model historical data as graphs. And we've done some work on comparing how do 2 different kinds of NoSQL databases can be used to store these. So we might come and show you that a little bit later at some point. And then finally, there's the document-oriented databases, and not surprisingly, that's the one we're going to talk about later, as I mentioned on the introductory slide. And one way to do this is to use MongoDB, and another is to use Apache CouchDB, but we're going to focus on MongoDB. So each one of these categories has unique attributes and limitations, okay? So there's no specific database really that's better at solving all problems. So you should choose, as a developer, you should choose and select a database based on their product needs. I have found them, I mean, lots of people find this, of course, that MongoDB works quite well, and the document-oriented databases are pretty good. Unless you've got specific requirements or data in specific forms that probably lend themselves nicer to either any of these three options as well. Again, as I mentioned already, we've used Neo4j in computer science to do some work, quite a bit of work for historical databases in digital humanities. So IBM and MongoDB provide really excellent summaries of the differences between all of these types of databases. And I've given you some links here and here so that you can have a look at them yourself if you want to review some of the work that you may have seen in earlier databases courses. They're nicely written. I've used some of them to make the summaries here myself. Okay, so let's quickly go through them. So key value databases, they're a simple kind of database where every item contains keys and values, and you've seen this because of all the JSON stuff that you've been doing, you know, and the value can typically only be retrieved by referencing its value. So learning how to query a specific key value pair is typically simple. Okay, key value databases are great for using cases where you have to store large amounts of data. You don't need perform complex queries to retrieve them. For example, storing user preferences, caching, all that kind of stuff. Okay. So wide column stores is our second one, and they store data in tables, rows, and dynamic columns, and that's a really, really interesting one. You know, where the dynamic columns are the key here. Okay, so wide column stores provide a lot of flexibility over the relational database tables, for example, because each row is not required to have the same number of columns. And remember, having tables with the same, you know, that you would have traditionally used in your relational database management systems, you were always told to have databases have the same columns, and so you would have gone through this normalization, the first, second, third, what's called normal forms, in order to ensure that you didn't, you know, waste any data space. Okay. It would have been so much easier if you could have a column, you know, some column, you just make it wider if necessary, you know. So many consider wide column stores to be basically two-dimensional key value databases. That's the way to look at it, okay? They're great when you need to store large amounts of data. You can predict what your query patterns will be, and wide column stores are commonly used for storing Internet of Things data, you know, and user profile data. You know, on the Internet of Things is where, you know, you connect your fridge, you know, or your toaster or your vending machine or, you know, your alarm or your baby monitor, all of that stuff, or something that you're wearing, you know, to the internet and make it available. Okay, two more. Okay, we have these graph databases I mentioned already, and they're great because they're useful for storing data in nodes and edges. And you've seen this from your database. Maybe from your database, of course, but you've also seen about graphs in your data structures and algorithms modules. So nodes typically store information about people, places, and things, and edges store information about the relationship between the nodes. So graph database excel in use cases where you have to traverse relationships to look for patterns such as social networks, you know, fraud detection, recommendation engines, all those kind of things utilize graph databases, and that's super for those. And Neo4j, of course, is great for this stuff. In fact, you can use MongoDB too, of course, you know, where you represent the data as documents, actually. So that brings us to document databases. So they store data in documents that are very similar to JSON, you know, objects. So each document contains pairs of fields and values, and the values can typically be a variety of types of things like strings, numbers, booleans, arrays, objects, all that kind of stuff. And they align with the objects that developers are working with in code. So that's quite kind of nice. So, you know, you take some database, you have some data in your application, you build, say it's a JS application, you store it as a JavaScript object. You can stringify this, turn it into a string, send it over the network to a MongoDB and database server, and it will be held in the database, and it'll work the other ways around. It's nice, you know. Thing about document databases is that they can horizontally scale out to accommodate large data volumes, and that's really attractive for us as developers of web environments. So there's a really good overview, including some really beautiful diagrams giving explanations of the different kinds of data that sits in these NoSQL database. It's in the free code camp, Bananhini Sarvan, And you can see this graph and some others that show you some nice descriptions of how they work. Okay, and what's important, I guess, for us is that, you know, I don't need you to know all that stuff. I just need you to know that they exist, and the one that we're going to be using is MongoDB. It's a document database, and it's consistently ranked as the world. And I found this information from MongoDB themselves, of course, on their own website, that it's consistently ranked as the world's most popular NoSQL database. According to the database ranking site, DB Engines. And you can find that DB Engines ranking site here. It's quite good. And one thing to note is that, you know, MySQL or MongoDB is probably 5th or 6th on the list of popular databases worldwide. You know, that's a combination of SQL and NoSQL. And at MySQL, the ones you've been using already for your applications, that's actually 2nd on the current list of all database engines. It's only outranked by Oracle. Okay, and you can, again, you can see the article that contains all of these nice images and descriptions of the data types at this freecodecamp.org article. Okay, so let's see how what we need to do in order to get going with MongoDB, and I'll give you some practical examples of this in the following lecture. Okay, so it's, remember MongoDB then, it's a general purpose document-based distributed database. It's built for modern application developers in the cloud era. And to get started, you're going to have to install a MongoDB client on your computer. The very minimum you'll need is this MongoDB client. Okay, and preferably, and if you can, and I understand that not everybody will be able to install something on a computer, the full client and server suite are available from the official MongoDB download center, and that's here. Okay. There is a commercial version of that as well, but the community server is perfect for our work. So visit the download center, download the version, or follow the installation instructions for your specific operating system. I use Mac OS Catalina, so I use Homebrew to do this. Okay, and I installed the Community Edition 4.2 for my work on my Mac for this module. But again, those instructions were on the download, the MongoDB official download center, and I mean, you can access it as a setup here. Okay, if you've downloaded the full, that's the Community Edition client and server, then you've got 2 main apps to concern yourselves with. There's Mongo, which is the client, and MongoD, which is the server. You often see D at the end of these services because it stands for daemon, which is a background process that runs on your operating system. I'm sure you've come across and seen this in your module on operating systems. Okay, so let's get through what these are then. Okay, so MongoD is essentially, it implements and provides the MongoDB database manager accessible via a network port on 27017, and that's no different to the MySQL port that you've seen service. You know, you run and set up your MySQL database, and you were using it on remote mysql.com. And in fact, we see a little bit later, and over the next couple of days, that you can do the exact same kind of thing with MongoDB Atlas and have your own online MongoDB database that you can work with and access remotely as well. So I like to have it running on my computer, but you know, I'll give you some examples using the cloud version as well. So you know, your information is stored safely in the cloud. MongoDB is the primary daemon process. Again, that's the service for the MongoDB system, and it handles all the data requests and manages the data access. It performs the background management operations, and you know, it's a complex program, and you can find more about that on the docs.mongodb.com, which is the really go-to source for everything related to MongoDB. And you can have a look at the MongoDB notes there. Okay, so the client, or the standard client anyway, is Mongo, and that's a command line app, and that's sometimes referred to as the Mongo shell. Okay, and that connects again, and you can connect. Initially, when you download and install these things, there's no authentication at all, much in the same way as we saw with PHP and MyAdmin connecting to your PHP setup that came with the XAMPP service. But it's best to set it up as an authenticated user, and I'll show you how to do that in one of tomorrow's lessons. Okay, but anyway, you use this Mongo app or shell to connect to the daemon, and that can be on the port on your machine, or it could be connect to the port that's in the cloud. Okay, and really that's just an interactive JavaScript interface to MongoDB, and you can use it to query and update data and perform all sorts of administrative operations. Like, for example, you can use it to create a new user, you create a new database and give that user permissions on that database, so you can do all that stuff. And you can find out loads and loads about the Mongo shell again at the docs of mongodb.com, and look up the manual for Mongo. get used to doing this, please. There's always going to be new things, new services, new software, and learn and understand how to use the online reference tools. They really are a brilliant aid to help you get going with development. So the Mongo shell and the daemon, they're all part of the MongoDB server installation. It is possible to just download the Mongo shell and run it as a standalone package if you don't want to start running services, so your computer's not up to running and services itself. So I'd recommend probably the very least downloading the shell, Mongo shell, and then creating an account in the cloud for a database, unless you want to get get involved and do the installation yourself. It's not hard actually, so it's fairly straightforward to do. You might not be the kind of person who doesn't like, using the apps and prefer a visual app like, say, PHPMyAdmin. Some people love this for working with their data rather than doing all the commands on the MySQL command line shell. So you could download something like Studio3T, and then, as long as you have all your login credentials, where the server is, what your username, passwords, all that stuff, that you normally need to authenticate, you can use Studio3T to work that as well. And I don't know if I have it installed as well. It works fine. It's nice. So, as I said already, an alternative to downloading and MongoDB, and it's possible to do all of this without ever downloading anything, is to create a cloud solution, and that's from MongoDB Atlas. Okay, and you can access MongoDB Atlas, mongodb.com/cloud/atlas. And it's really a service that's equivalent to the remote MySQL service that you've been using already or saw me talking about in last week's lectures. So you don't have to host the server yourself. You can create a free installation and use local or online shell tools to access your Mongo database. It also means that you can actually access them from programs that might be hosted in REPL.it or from phpfiddle.org or whatever. Okay, there are also some great sites that provide walkthroughs for setting up a MongoDB Atlas account. When I was creating the class, and I created a second account, and they worked out quite well. Nothing has changed much. It's very doable. And I have screenshots that I can post to show you how I got there. Okay, I'll make a little document that I'll post on Moodle for you, and I'll cover it in one of the lessons, in case you have difficulties trying to create your MongoDB Atlas account. Okay. And what's important about this is that you absolutely will need access to a server, a MongoDB server for the module, because we're going to be developing tools with PHP and Node.js to access the database, just as we did with MySQL previously. Okay, and I'll demonstrate using MongoDB Atlas in the next lessons, and we're getting started with MongoDB one, and then and once you've got that set up, you'll be able to do the assignments, and you'll have some form of examination, which will require you to be able to know how to do this and use this, and you'll need it to be able to do your assignments anyway. Okay, so let's go now and spend a little bit of time comparing document databases as provided by MongoDB with a relational database. So you know a lot about how to model data already, and I want to let you know that you can bring what you know to modeling in a NoSQL environment. Okay, so there are three key terms that we need to be able to think about. We need to know about. We need to know about documents, we need to know about collections, and we need to know databases. So if you want to fully understand how to use MongoDB, it's important to understand these three key terms, and these are the three data structures that you have, okay? So if we think about the relational database world and the MongoDB world, I'll give you some examples here for this as well. A row is equivalent to a document. Okay, and so here, for example, is a document. That's not unlike, a JSON description or a JavaScript object or something that you would have seen already. Okay, in the relational world, a column corresponds to a field, and we've seen this before as well. So fname Joe and fname here, it's just a field, and a table is a collection. So a collection of documents containing fields. A table is a collection of rows that have columns. Okay, and here, for example, you have them all. It's just separated by commas. There's probably some square bracket holding all these things here, or some, or there might be some, something like this. Okay, so and remember, notice that the MongoDB documents are specified using JSON. So So what it tells us in English over here, I goes, the document that represents information about a member whose F name is Joe has fields organized in name value pairs, and documents can be collectively stored together for some logical purposes as a collection. Okay, and those collections form the database. Okay, a MongoDB database consists of one or more collections, just as a relational database management system database contains a collection of tables. And that's it. Once you get this, you can understand the various connections. And I think that when I maybe I should quickly just show you if I can start up my data from recently. I'll restore the session. So if you'll know, just up here, when I generated customers, I generated some data for use in my last example. I was just able to generate data here, just randomly generated using my app. And then I was able to generate the code that automatically created the SQL for inserting it into a database. But I was also, and you may have missed this when I talked about it in one of my lessons, I was also able to generate a JSON structure or a JSON document associated with these. So these documents contained fields, and I had a collection of these, and I was able to see a corresponding structure between a table here. Okay, so you might be able to go back and have a look at some of that stuff and see how they connect and how they relate to each other. Okay, so in other words, it is possible to switch between them, really. I guess that's what I'm saying here. Okay, so what about the primary keys though, and all that stuff? So there's no MongoDB equivalent to a traditional relational database management primary key or the alternate key or any of that stuff we saw in the previous days. In the physical model for relational database management systems, we defined one or more columns as the primary key in order to identify a given row uniquely. So that will equivalent to how do we specify a document. There's no requirement for MongoDB because it always supplies this identifying field ID that's automatically added to a document when the document is inserted into a collection. So for example, if we look at here, this is the prompt for the MongoDB, the Mongo shell. So I'm using this database test. So this is telling me I've switched to the database test. Now I'm inserting a document into my collection foo that's held in this database. And it gives me this result. That it's inserted one record, and then I can find the documents in the foo collection in the database, and you'll see here's Joe blogs back again, and you'll notice the ID was created, and the object ID is this long, huge object ID. And I'm actually just going to delete that then. Okay, so I did that because this took directly from me playing with the Mongo shell. Okay, so the ID field that comprises an object ID instance, and that guarantees uniqueness for this document. And it's shown in the fragment that's there that creates a simple document in a collection foo in a database that's specified by DB, which happens to be test in this particular instance. Okay, and you can look up object ID in the MongoDB manual, and it'll tell you everything you need to know about object IDs. Okay, in fact, here's the reference for it. Okay, you can check that out there. Okay, so MongoDB supports the creation of indexes on any given field that boosts query performance, and it's an auto-generated ID field is automatically indexed, so you don't have to do this yourself. Creating too many indexes will have a negative impact on performance, however. And you can find a little bit about that on manual, but I don't think for your work you're going to have to worry too much about indexes really or keys in this particular example. Okay, so we now know that what the corresponding terms are for rows and columns and tables and collections and fields and documents. So how do we go about modeling data with NoSQL? So data modeling with MongoDB is different to the process undertaken for relational database management systems physical implementations in, say, MySQL. It is possible to have relationships that connect documents using a reference, and that's called a normalized model. But it is also possible to use an approach called embedded documents. I need to correct this a little bit. It doesn't look too good. Bear with me 1 second. Possible creation approach. Okay. Yep, so it's possible to use an approach called embedded documents, and that's an embedded data model, and that's called sometimes also referred to as a denormalized data model, which distinguishes from the normalized model. Okay. When we were working with relational databases that we manipulated using SQL, we went through a design process, ultimately that led to an ERD, and we eventually determined that and designed the table schema before inserting the data. With MongoDB collections, by default, it does not require the documents to have the same schema. So, you can have the equivalent of a table containing documents, and they can be all different. I don't know why you do that, but they can be. So the MongoDB modeling guide is really useful. You can see a little bit about it down here in this link. It tells us that the documents in a single collection do not need to have the same set of fields, and the data type for fields can differ across documents within a collection. Okay? And this flexibility facilitates the mapping of documents to an entity or an object. And each document can match the data fields of the represented entity, even if the document has substantial variation from other documents in the collection. That is really powerful stuff, okay? And you might need to think a little bit about that and maybe play with the Mongo shell just to verify for yourself. In practice, documents in a collection will usually share a similar structure. I mean, why would you not do that? There are instances when you might not, but like in general, they're going to be similar. And you can enforce some actual document validation rules for a collection during the update and insert operations using something called a schema validation. So if you tried, you've seen this with PHPMyAdmin. If you try to insert, a string into a Boolean field, it'll complain, and you get an error, and you have to handle the error. So the same thing goes on and can happen. That's a schema validation, and the same thing happens here. Okay. So we're then going to look at two approaches to designing data models in NoSQL. Unsurprisingly, it's the normalized and the denormalized or the embedded approaches to model design. Okay, so let's first and foremost look at the normalized model. Okay, and that uses references. So using references, it's possible to create a series of related collections in order to establish a normalized data model. Okay, so references store the relationship between the data by including links or references from one document to another. And then applications can resolve the references to access the related data. They're normalized data models. So for example, a normalized data model could be accomplished by defining a key, okay? You could call it key fields, not a primary key, but just key fields like in a customer ID and address document, which forms the relations or reference between a customer and an addresses collection. And not surprising, we saw this kind of thing last time. So you have a customer ID, you have an address ID, and you have a customer ID and address ID in another document, and that really references and that denormalizes. And remember, we'll just go back a couple of slides here. You see this ID here, object ID, those are the IDs that we ultimately store in here, okay? They're the IDs that we store. I'm just putting in numbers here just to make it a little bit easier. Now, some authors do not advocate this approach at all, okay? Because they say it defeats the purpose of using a NoSQL database because it relies on your database driver functionality to handle the embedded links between connections, or you will be required to manually write code to reference references. All valid points, because this means that you've got some unnecessary overhead that can be avoided by using a different model, okay? So you can find out more about references if you click through to this link on references, okay? But in general, the manual recommends using normalized data models when embedding would result in duplication of data that would not provide sufficient read performance advantages to outweigh the implications of the duplication, to represent more complex many-to-many relationships, or to model large hierarchical data sets. And it also provides then referencing, facility to join data across collections. It does this, even though we don't have to deal with joins, as I mentioned earlier. But really, what's important to realize here is that these perspectives are contested. Okay, so some authors will tell you, oh, you don't do this. You don't do normalized data models. You must use, a denormalized model instead. And then, but actually, in some cases, it's a good idea to do that. Okay, it's a good idea to use the normalized model. Okay, so be very skeptical of articles and authors who tell you there is only one way to do it. So the embedded data model is the alternative way. And some say better, okay? Some say better for data modeling. And the way to do that then will be to collapse the normalized relationships and fold the related information into embedded documents, as we have here. Okay, so here we have a data model for Joe Bloggs, and we have the shipping address and billing addresses embedded rather than having two separate tables as we could have done here. Okay. Yeah. So, and we can find a little bit more about embedded documents in the data modeling introduction again. Okay, so what happens is that they capture the relationships between the data by storing the related data in a single document structure. Okay, so MongoDB documents make it possible then to embed documents in a field or an array within a document. And you've seen this with JSON. You know about this kind of stuff in JSON, where you nest objects within objects. Essentially now you're nesting documents within documents. Okay, and these denormalized or embedded models allow applications to retrieve, and this is the important bit, they allow you to retrieve and manipulate related data in a single database operation. That's powerful. Okay, so the embedded data model allow, as I said, you to be able to store related pieces of information in the same database record. Consequently, then you may need to issue fewer queries and updates to complete common operations in your database, and speeds things up for you. So, according to the manual, you use embedded data models when you have contains relationships between entities. So, one-to-one relationships with embedded documents, and that's in the modeling guide, and I'll deal with that in the next lecture. You might have one-to-many relationships between entities. In these relationships, the many or the child documents always appear with or are viewed in the context of the one or the parent documents. And again, you can have a look at modeling one-to-many relationships with embedded documents on the MongoDB modeling manual. In general, though, embedding provides a better performance for read operations, as well as the ability to request and retrieve related data in a single database operation. Okay. So embedded data models make it possible to update related data in a single atomic write operation. And that's quite powerful. Because if you think about the example that I worked at last time, when I wanted to be able to create a user and their address information, I created the user, I created the address, and then I added, in the denormalized approach that we had in the relational database model, I then created another entry. You saved the two keys, and I included those into a document, into another table, and that's the sort of thing that would happen here as well. If I wanted lots of writes, now I could do it all in just one write to one collection. Okay, so how do we approach document design then? How do we do this? So the key decision in designing the models revolves around the structure of the documents and how the application represents relationships between the data. So, MongoDB allows related data to be embedded in a single document and also use references to other documents. So, which do you use? So one approach when designing designing documents that are ultimately going to end up in collections is to begin the design process by identifying the views that will be required. That requires you to kind of work backwards to design or decide which documents need to be created. And that was the approach used earlier. For example, application might need to show a display with a customer name and shipping or billing address. And either approach will work for storage. You will have to decide on what works best before you design your application. Modeling the application data from MongoDB should consider various operational factors that impact on the performance as well. Different data models can allow for more efficient queries and increase throughput of insert and update operations, etc. So you need to think about that too when you're designing in the big scale. But you can think about it in the small scale as well, of course. Because good practice early on will lead to good practice later on. Okay, so quickly let's go through some data modeling then. So we've seen that we saw conceptual, logical, and physical modeling for relational database systems. So we were already familiar with the entities, the documents, the relationships, cardinality, all that stuff. So relationships in the NoSQL context show how MongoDB documents are related to each other. Okay, that's really what it's about. So relationships show how MongoDB documents are related to each other. So here's a brief summary of the different kinds of relationships that we're interested in. Okay. One-to-one relationships that exist when one object of an entity is related to one and only one object of another entity. There's one instance, in other words. One user can have one and only one birth date. So if we have a document that stores user information and another document stores birth dates, there'll be a one-to-one relationship between them, for example. So that's that one. A one-to-many, or we say 1:n relationship, and that exists when one object of an entity can be related to many objects of another entity. So for example there, you could have a one-to-n relationship or a one-to-many relationship between a user and their contact phone number. So they can have more than one or many phone numbers. A many-to-many relationship, that exists when an instance of one entity is related to many instances or objects of another entity and vice versa. So in the case of users or customers and items purchased by that customer or user, one user can purchase more than one item, as well as one item can be purchased by more than one user. So it's okay, you can do this. And remember, we've seen this logical design already. We can still use it. Okay, we can still have a sense of understanding the entities. So we don't throw out this data model, we can look at the entities, we can look at the relationships between them, and then we decide how we will physically realize these. So, it's not like you got to forget all that stuff, okay? See, this helps us with the cardinality and understanding cardinality, and we need to be able to do that. The thing is that we're going to be designing physical database in MongoDB, and we're going to be using documents that are specified using JSON rather than using database tables. Okay, so what's coming next then? Okay, so what we're going to do over the next couple of lessons then is we're going to examine database modeling using documents in more detail. We're going to discover how to realize one-to-one, one-to-many, and many-to-many relationships. We're also going to see some basic MongoDB commands and how to create, search, and manipulate databases using the Mongo shell. We're going to look at a local database instance, and we're going to look at MongoDB Atlas. And we're going to see how to interact with MongoDB databases using both PHP and Node.js. And we're going to cover those in the next lecture's lessons. And I have a document prepped already that I'm going to work through, and that will probably form the basis of the first one or second lecture. I'll probably get started with a small example for you. Let me just open this document and show you some of the stuff we're going to work with. These are the lecture notes for this lesson. And I didn't want to do all of it, but what I will do in the first lecture is I will actually work through some data modeling with MongoDB. We've seen this already, and now I'm going to go through and show you some specific examples of how you can model one-to-one relationships, how you can model one-to-many relationships using embedded systems, how we can model reference one-to-many relationships, and how to model many-to-many relationships. I just thought it would be just a bit dense to try to do everything, and we'll do some basic MongoDB commands to make all of this happen. Okay, I didn't think it would be. I thought it would be too much to just do everything in the one lecture today, because there's a lot to get and understand initially. Okay, so we'll do that. Thank you very much for watching, and I'll see you online. Thank you very much.